Hey everybody, it is May 8th and this lesson is on 11.3, which is multiplying radicals. So I don't know if you all are starting to feel tired, but I'm starting to feel tired. This is my second algebra video for the day. So before we get into anything, the first thing we should do is go to the Lord in prayer. So Heavenly Father, we want to praise you and thank you and give you all honor and glory to your name. And we ask that your will be done, not only in heaven, but also on earth. Grant us wisdom from heaven. Don't let us trust the wisdom of the world. And we pray that you'll grant that same wisdom not only to us, but to the authorities that are ruling us on this earth. We love you. In Jesus' name, amen. All right, guys, so we're going over radicals, and specifically we are multiplying radicals today. Before we get into it, this is a easy lesson, should be a rather brief lesson. It's very much using what we've done in the past two lessons, which is just knowing radicals, that was 11.1. Simplifying radicals, which was yesterday, we will be required to do some of that in order to multiply radicals. And then today, we're just taking both of those things, multiplying radicals. On Monday, we're going to be dividing radicals. Then we have a few more lessons on radicals, along with some quizzes, and that will finish up your year in algebra. But hopefully that's given you enough stuff to be able to use in geometry, as well as algebra 2, whatever you're going into next. So the first thing I want to do is just go over perfect squares, perfect cubes, because remember, if you recognize what these are, it helps so much with simplification. So as we're going through, perfect squares, 1 is 1, 2 is 4, 3 is 9, 4 is 16, 5 25, 6 is 36, 7 49, 8 64, 9 81, 10 100, 11 121, 12 144. Then we get into the weird ones that you probably don't know. 13 times 13 is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, and 19 squared 361, ending up with 20 squared is 400. So you recognize those roots. Going to our cube roots. Cube roots would be multiplying it 3 times. So 1 cubed is still 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed 343, 8 cubed is 512, 9 cubed is 721, 10 cubed is 1,000. So that's just going over that. Remember, if you can recognize these numbers, not only just they're sitting out there and it's a cube, but as you're factoring it down, that would help too. So yesterday, we were factoring all the way down. That will still help today when you have these huge, huge numbers that you have no idea what they are. Always go back to prime factorization. Even if it's a simple number, you could do prime factorization. But today, as we're multiplying radicals, first let's go over the product formula, or the product property. Let me move all the way there. I'll just show my head. So the product property of radicals. First, the big thing as we're looking at this is you need the same index number. Same index number. N, yeah, N. I can multiply those and I can just stick them under the same radical sign as N. Now what we're doing is using some simple numbers that we used yesterday, and kind of using this property backwards, showing you how you can go backwards, forwards, and we can use this property several different ways. So, if I had just 12, yeah, I could do prime factorization on that, but you probably already realized in the products of 12, like 4 and 3, there's already a perfect square that's right there. So, if I have technically I could separate that out just like this product property. I could have the radical of 4 and the radical of 3. I could simplify that out all the way by taking the square of that 4, which is a 2, and leaving it multiplied to the radical of 3. Same thing right here. 18. I could use prime factorization, but I probably already know there's a perfect square that is a factor of 18, and that is 9. So I could write it out as this product, as this multiplication, expression, and then I could take the square of 9, it would be a 3, and I could leave it multiplied to the radical of 2. There's another way to look at that. It's what we were doing today. It's technically, if my index number is the same, and without an index number we know it's squared, then I can stick the variables, I can stick those numbers underneath the same radical sign, and it's the same thing, and just leave them as multiplied. So 50, technically, that would be 25 times 2. I could use the prime factorization with that if I wished, but I kind of know that's 25 times 2, and 25 is a perfect square. So what would happen there? I would go ahead and pull out the 5 as the square root. I was trying to say cubed root, and leave it multiplied to the 2. Same thing here, except you all probably know this. If 25 plus 25 is 2, 25 plus 25 plus 25, oh, that would be 25 times 3. So I'd go ahead and take out the square, 5, and then I would leave under there 3. Last one is 245, and 245 is one of those weird ones, but we're not going to do the prime factorization, though you would, if you did the prime factorization, you would automatically see the perfect square that's in there, and that would be 49 times, I lost it, 5. So 49 times 5 is going to end up being the 2 factors that are under there. I could, once again, if you get confused, use prime factorization. We saw that yesterday as being a real easy way to pick out my squares, to pick out my cubes. So the perfect square would be 49. I would go ahead and pull that out, that's 7. And go ahead and leave the 5 under the radical sign. So that's 2 things we just need to go over, just to kind of show you as a way to get back into using that product property of radicals. Well, as you go through the examples they've given to you, they just kind of show you you've got these 2 numbers, they're sitting under a radical sign. Well, I could go ahead and stick all of those underneath, and then suddenly those 2 numbers, I might end up with a perfect square. Like on example 1, I ended up with 2 square, and I ended up with a 3. And that was, I was originally starting with the radical of 2 times the radical of 6. After I put those both under a radical sign and broke them down into factors, I had 2 2's, or I had a 4, or I had a perfect square, so I took out that 2. And then so forth and so on. You can just see kind of what you're doing as you go through there. Now if you look at example 2, technically what happens is the numbers underneath the radical sign multiply together. The numbers outside the radical sign also multiply together. It's just once you have all that done, you may be able to pull out more perfect squares that would go toward the square that's been, the number that's been left outside the radical sign. So we're moving from that. If I was just, popping through here, just for also remember, just going to the top of 442. Same index number. You can't do a cube root or a 5th root multiplied to a square root. That's not going to happen. It has to be the same power or the same index number. That's what that's indicating for the product property. So we are going to go over, where did I put it? It's way over here. We're going to go over some quiz questions that you have, or I'm going over specifically questions that are really similar to your quiz. I am going through some work. I expect you to do some work. They've given you spaces on your quiz. We're starting on the quiz like 11.3 and 11.4. They've given you some spaces on your quiz for work, so you should have it. Nobody really can pull out all these factors and all this prime factorization out of their head. Anyway, it's May. I have not seen any type of that level of, what could you say, savant, that savant level of being able to multiply and come up with figures in my head from any of you at this point. So let's look at some quiz questions, or some questions that are similar to quiz questions that you have on your quiz. So starting out, we've got the radical of 75. And then we have that multiplied to the radical of 6. Well, automatically, some of you are going to say, let's just go ahead and multiply 6 times 75. Don't do that. You're going to have this big mama number that's going to make your life even more miserable trying to break it down. What you should do is go ahead and stick it underneath the same radical sign, and then start breaking this thing down into some factors that might help you. So what would be the easiest factors? One of them we just figured out, right? So this one was 3 times 25. Or if you broke it down into prime factors, that would be 3 times 5 squared. If you leave it as 25, that's fine too. Just recognize that. What do you have? What are the factors right here of 6? Oh, that's 3, and that's 2. So technically, look at what's coming out of here. So I have the 5 squared. It's coming out. That is just a 5. And I'm just going to show you, we could have left that as a 25, and you would probably say, hey, that's a perfect square, and we'll go ahead and pull it out as a 5. Or you could have written it as a 5 square. That's perfectly fine too. But there's also 2 3s. So that means that's a 3 squared. Let's go ahead and pull out that 3 as well. And what do I have left under this big mama radical sign that I made for some reason? We have a 2. Am I finished? No. I need to go ahead and multiply my numbers out here. So my final product, or my final product of radicals would be 15 multiplied to the radical of 2. So that's 1, you have a similar problem with that on your quiz. Hold on, I forgot to put my recording sign, I'm afraid somebody's going to come in. Okay, maybe people will at least knock if I put my recording sign up. So that was numbers. That was pretty easy, right? Not a big deal. Let's add a whole bunch of variables to it. It's still not that difficult. You just have to start looking at exponents and figuring out what's going on with the exponents. So my next one, that is somewhat similar to what's on your quiz. We're going to multiply together 2 cube roots. So right off the bat, they are the same. So you look here, look there, they're the same. I can go ahead and put all of those underneath, or I can go ahead and multiply those together. If they were not the same, I would not be able to do that because I need the same index, okay? So I have 18 x squared with a y, and then I have 24 with, hold on, cannot see it, it's too far away. So I have x to the 4th power and y to the 4th power. Now, we can go ahead and put all of these under one big radical sign. And like I said, if you wanted to make your life miserable, you could go ahead and start multiplying 18 to 24. Okay, I'm just going to do 18 to 24. Yeah. Now you got this big mama number you're going to have to factor back down. Why not just go ahead and just make your life easy? Either bring it all the way down to prime factorization, or bring it down and say, do I have some perfect squares in there? Like this one, these numbers, I'm going to put all the numbers together. So this number, that would be 9 and 2. Got a perfect square right there, right? I could just, to bring it down into prime factorization, I could say, okay, there's 3 squared. All right, let's think about 24. Going into the prime factorization of 24. So I basically have 3 times 8. You could put 4 times 6, factor that down, right? 2 times 12, factor that down into primes. But if you think cube roots was 1, since I don't have a perfect square, but if I'm looking for cubes here, do I have one that's cubed? Do you see over here a potential factor of 24 that would be a cube root? Do you see the 8? So technically, that would be 2 cubed. 2 cubed times, what was that 2? A 3. And you can probably already start to see what's happening here. But for right now, let's just go ahead and put together our exponents. We learned 2 lessons ago that technically if I'm multiplying if I'm multiplying these variables, what happens to my exponents? Those exponents are added. So now I have 2 plus 4, that's x to the 6th power. And I have y plus y, the 1 plus the 5, that is going to be y to the 5th power. Now, we are going to kind of situate this out and try to figure out what exactly do I have. Well, as I go under here, there's one screaming at me. I have this 2 that's cubed. That was my 8. I bring that out as a 2. But there might be something else that might be screaming at you too. So I'm just going to mark that out. That's 1. All right, that's 1. That needs 3 here as well. Right here, I have 3 squared, but then I'm multiplying it again by the 3. So guess what? Technically, if I put those 2 together, that would be a 3 cubed. So that's going to have to come out as well. So that 3 is going to be cubed. So see? Technically, I could put that and that together, and then ta-da, it would be 3 cubed. I need to bring 3 out. What number is left? Just number. We'll fix it and make it pretty here in a minute. What number's left? The 3's are gone. Only 2 is left under there. Only 2. Oh, I need some spacing there because we're going to start bringing out our exponents of the variables too. So far we have 2 left under there. All right, so an easy way to figure out what your exponents are for your variables, since we've already got them together, is remember, I'm going to take kind of those exponents and divide it by 3. But, that might be a little confusing because you're going to say, wait a second, that 5's not going to separate out. Well, technically, what I need to do is I need to take the 3's out of that 5 and leave what's ever left in that 2. And what's ever left from the 5. Take the 3 out, subtract that from 5, and leave it right there. Now, with this, I could go ahead and divide that out, and I'd have exactly what exponent would come out. So with the x, I'm going to go ahead and just divide the 6 by the 3, and I have x squared coming out. Now, with the y, technically what's happening with that y? I could divide that by the 3. You could do it either way. I could take out 3 of those by dividing it by the 3, and that would come out one time, but I still have some y's left. So basically it's 5 minus 3, or 5 divided by 3, leaving 2 as a remainder. And so under here, I'm going to have y squared that would remain there. Still isn't completely finished. These are looking good, right? What's the last step to do? I need to multiply this. So my final step, after multiplying the 3 and the 2, would be 3x squared y. What's left underneath is 2y squared. That's me multiplying this radical. Now when you get into your homework, and then you have one very similar on your quiz, they have given you a geometrical question on your quiz, and you have some geometrical questions in your homework as well. But I mainly want you to concentrate on, if you're doing your homework, like 1 through 35. And there's some geometrical questions in 1 through 35 if you do 1 through 35 odd. Once again, you don't have to turn in your homework. This is mainly practice for you to understand what this concept is. So what we have on your quiz that is very similar to some that's in your homework is we have the area of a rectangle. So if we remember what the area of a rectangle is, that is area, and that's length times width. Area equals length times width. So we know that the width of the rectangle has this weird looking radical going on in it, and that's 4 to the radical of 6. The length of the rectangle is going to, hold on, that's an L, not a 1. I'll do it like that. The length of the rectangle is another weird radical expression. And that is to the 15th radical. Yay, right? Happiness, right? So what we can go ahead and do is we can use our product property to smush everything together. The easiest thing to do is the 4 and 2 are just going to go ahead and multiply to make your life easier. You don't have to break those down. So that's going to become an 8. And then technically what's left is we have the 6 and the 15. Yes, you could multiply those together and make your life miserable, or you could go ahead right now and break them down into prime factors here. I mean, because look at it. I know that the 6 is going to break down into prime factors of 2 and 3. And hey, the 15 is going to break down into prime factors of 3 and 5. That's why you don't have to multiply these big numbers, get this big number, and then bring it all the way back down to these little numbers. Leave it in the little numbers, break it down. Now I start looking. Do I have something squared that I could potentially bring out? Oh, I have 2 3s. That's one way to look at it. Or that's a 3 squared. 3 times 3 is squared. So I'm going to bring out those 3s. So now I have 8 times 2. What's going to be left underneath there? It's going to be the 2 and the 5. We're still not finished. We just need to finish up with the multiplication. So this number is going to become 16. The number underneath the radical will become 10. See how that's not that difficult. That's everything we've learned. Sometimes you all hit these geometric questions and you freak out because it's geometry and they kind of give you what the formulas are. You just need to calm down. Plus you got your whole book. So that kind of gives you all your quiz helps that you might need for your quiz questions. We've gone over how to do the product property as well as, what was the name of it? Multiplying radicals. Yeah, multiplying radicals, and to that. Yeah, I kind of did the quiz help on this side rather than move down. But oh well, you all got the gist of it. So hopefully your day is, it was rainy. Now the sun is trying to come out, which means it's going to be humid as all get out when I walk outside. My hair will go flat or poof. You never can tell. So have a good rest of the day. Have a good time on all your quizzes, I guess. And if you have any questions, feel free to give me a text. Some of you are doing that, and that's wonderful. Love to hear from you. Do not feel like you're bothering me. That's my job, is for you to, give me a text and ask me questions. So have a great rest of the day.